Time. Good afternoon. My name is Jeff Woolsey. I'm a principal program manager at Microsoft. Forgot to put my Twitter handle on there. My Twitter handle is @WSV_guy. It's a pleasure to be here. Huge thanks to our friends here at QCT. It's really awesome to be here and to be talking about hyper-converged infrastructure and what's going on. Listening to the keynote this morning, listening to everyone pretty much agreeing across the board. We all understand that hybrid is where everybody wants to be. I'm so glad we're having that conversation and we're not trying to argue about, oh no, it's all public or no, it's all private. No, I haven't believed that for a very, very long time. So what I wanted to do today, and I'll be honest with you right off the bat, I have like 6 weeks of content I'm trying to cram into an hour, so I'm going to do my best on that. What I'm going to talk to agenda for today is what our customers have told us. What are we literally hearing from customers who come and chat with us behind closed doors? What are the things that are top of mind to them? What is literally the Microsoft Cloud? We've been talking about this for years. It's no secret. We're super transparent, but I want everybody to understand exactly what it means. And then I'm going to talk specifically about Server 2016, and we've made some huge investments specifically around hyperconverged. We're actually doing a whole bunch of new things that leverage and in fact require new hardware. Things that I think customers have told us right off the bat are very excited to go buy servers to take advantage of these new technologies. Security is a huge one. I'll be honest with you, if there's anything that shocked me in the keynote, I don't think I heard security mentioned once. And that was, honestly, I almost had to look around and say, am I in the right room? Because I'm going to tell you right now, top of mind for customers, there are too many stories about companies getting hacked and not knowing about it for months. This is literally happening every day, okay? Just ask Marissa, okay? I lived in Mountain View for 10 years. I actually lived in Silicon Valley for a long time. I was actually part of an acquisition that took me up to Microsoft to do virtualization. So I know this area, I know Silicon Valley, and security is literally top of everybody's mind. And there is no conversation where we have with a customer about cloud today where there isn't, okay, now we need to talk about security. So that's very much top of mind. How can we get the benefits of public cloud in our data centers? When we show people what a data center at Microsoft looks like, and we've shown pictures before, and they see literally, something that's 20 times the size of a Costco warehouse that's literally full of servers everywhere. People want to know, how can I take advantage of that and run that on premises? How can I take those learnings from there? Another one is, what do I do about shadow IT? This comes up over and over again. And people need to ask themselves, why is shadow IT occurring? 99 times out of 100, it's because developers went to IT and said, guys, we need to work on this new application. We need it built yesterday, and here's all the hardware. And they say, yep, you can have it in 6 months. And so people get frustrated and go start building it elsewhere. And then later, somebody has to figure out, well, wait a minute. Where did this bill come from? Who's managing this? How is this part of my whole IT infrastructure, and how am I managing it? Customers tell us, quite literally, I will ask this question in every conversation, where do you want to be in 5 years? Where do you want to be in 10 years? Where do you want to be in 20 years? I don't care, don't tell me what you're doing today. I'm not interested in the tactical. Where are you going as a company? And literally these are the responses I get. Hybrid cloud is our strategic direction. We're all in on hybrid cloud. This is my favorite one. Hybrid, of course, seriously, is another answer. I asked this of a CEO, he said, wait a minute, Josh, is this a trick question? Am I missing something? I said, no. I just want to make sure that this is where your head is at because I'm interested if you think there's another answer. And literally everybody's saying, oh no, it's hybrid. The only question in my mind, and the only question I hear from customers is, what percentage is running in public and what percentage is running in private? That's really the only question left. And for the very conservative companies, usually European companies, very often German or Swiss, they'll say, you know what? Maybe in 5 years, maybe we're 50-50. Okay? Maybe. More aggressive companies will tell me, oh no, maybe it's 80-20 public. But we know it's going to be hybrid. We're trying to figure out what that mix is for us, but at the end of the day, it's going to be hybrid. So we understand that IT is being pulled in two directions. Number one, they're being told you need to provide secure resources. Okay? Make sure you're protecting the company's crown jewels. At the same time, they're also saying, but you got to go faster. You got to go faster, 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 faster. And IT's in the middle going, wait a minute, how do I do both of these things? And at the same time, the reality is very real that by 2017, 50% of total IT spend will be happening outside of formal IT. So that's the also happened in the keynote this morning, which was we talked about, look, we're seeing more of a shift between public and private. And this is not a surprise. This is nothing new. The question is, what does that percentage look like? And more importantly, how do we help our customers build the best hybrid cloud solution together? Because at the end of the day, they're tired of buying hardware and that doesn't interact or integrate with what they're trying to do long term. Don't sell me another standalone solution over here that I've got siloed solutions all over my infrastructure. So one of the things I like to point out, and let me be very clear as what the Microsoft cloud strategy is. We've been saying this for years. You know, we understand people are going to continue to build on premises, and that's totally fine. That's great. I can easily describe this in one word, by the way. The word is control. I will literally have a customer come and say, Jeff, I have a workload that has to run in a German data center on German soil by German citizens. Are you going to try and push me up to Azure? And my answer is no way. This has nothing to do with technology at all. This is a data sovereignty question. This is a compliance question. This is a regulatory question. If that's what you have to deal with, great, let's help you build your best private cloud. Let's do that. At the same time, we're making our huge investments in our public cloud. And our public cloud is much more than IaaS VMs. Everybody gets fixated on IaaS VMs. Honestly, at the end of the day, I've been working on hypervisors for 17 years. I'm the first one to tell you hypervisors are super, super cool. They are super, super, super awesome. They're also not the end state. You tell a developer today, I need to build a new app. He doesn't ask you for VM. He wants a PaaS endpoint. He wants a SaaS endpoint. I don't have to carry around an operating system and manage an operating system and do all that. Azure does all three, PaaS, SaaS, and IaaS. And I can easily describe the public cloud in 2 words, scalability and agility, also mentioned in the keynote today. I sat there and I said, boom, we are 100% in agreement on this. Because if you want to set up Hadoop today, you can buy racks and racks of servers, you can buy racks and racks of storage, you can buy racks and racks of network, you can set it up and you run. You may decide, you know what, let me just try it out in Azure and see if this is really what I want to do. And if I do want to do it there, great. Or if I actually do want to run it on premises, great. But at least I can do it very, very quickly and very, very easily. Well, this is how this brings us to Azure Stack. Now, Azure Stack is something I actually publicly demonstrated last year for the first time at Ignite. And we just announced Technical Preview 2 last week. Azure Stack is quite simply about bringing Azure to our customers' data centers. This is about bringing Azure services, not just VMs, but PaaS services, SaaS services, on premises, so customers can run it in their data centers. Now all of a sudden, you have a consistent hybrid cloud. You actually have the same application model, and this is what customers are looking for. Because strategically, they want to know, hey, you know what, Jeff? My developers, when they go write a new application, if I can just tell them, write it for Azure Stack, we'll run it on premises, and I can move it here or I can bring it back without any code change, that is strategically important to me because that is what hybrid cloud is all about. So that's what we've been very focused on. And in fact, our Azure ecosystem, we have 34 regions, we have hundreds of service providers, we have thousands of enterprises. And this is important to us as well because when we think about cloud, you don't want to invest in a cloud that tomorrow is gone. There was a company about 2 years ago called, I believe they were called, make sure I get them correct, I believe it was Nirvanix. And they were a software, yeah, people are shaking their head, yes. Nirvanix, they were a storage cloud. And it was like, oh yeah, we're the cheapest storage cloud, put everything up on our cloud and everything will be great and everything will be fantastic. And people did that. And everything was great until they went out of business. Okay, and what was really sad is, you know how people heard about it? They heard about it first on Twitter. They didn't even hear about it from the company. Okay, they heard about it on Twitter. And I heard about it pretty quickly. You know why? Because all of a sudden my inbox went bananas. All of a sudden we had people from all over the world saying, oh my God, Jeff, please help us. We need to get our stuff out of this and into an Azure cloud. I had a guy actually email me and say, can I call you please? And I said, okay, here's my number. He called me up and I said, what's going on? He's like, I'm really stressing out about this. And I said, why? And he said, look, I've done the math. I can actually take a rack of servers, drive it to their data center, and start copying all of my data out of their data centers right now, and I still won't have it done in time. I said, ooh, that's not where you want to be. This is our Azure ecosystem. Our ecosystem is not only Azure, but it's our enterprises that, guess what? they want Azure Stack solutions in there as well. On top of that, we want them to deliver software solutions, guess what, that we have announced last week that we will syndicate into an enterprise. So think about this. You're a software company. You're building software solutions. You're making them available on Azure on our public cloud. But what about someone who just set up a brand new, awesome new QCT Azure Stack in their enterprise? And guess what? They want one of those solutions, and guess what? It's actually syndicated and they can run it on premises behind their firewall. That is now real, true hybrid cloud. That is literally the same app that was running in Azure, could be running in Azure Stack in an enterprise. That's how we think about cloud. Very briefly, our private cloud today has been Windows Server, System Center, and Azure Pack. We are taking what we've learned from Azure and we are bringing it over here. How did I do that? I did it through the power of talking to someone in marketing who built me this slide, because I'm on the dev side of the house, but somebody in marketing came up with this. So essentially, up to now, when we have a cloud solution, our cloud solution has been on Windows Server, System Center, and Azure Pack. Okay, Azure Pack is actually free code. It's actually literally the Azure portal that includes IaaS and PaaS services we give to customers today, so they can literally build this today. For that part's free. And customers came to us and we said, Jeff, this is really cool. It's got the same Azure portal, it looks like Azure, and it feels like Azure. The problem was when they started to build applications, they said, you know what, Jeff, it's Azure-like, it's Azure similar, but it's not Azure the same. What we really want is Azure the same. So what we did was we said, okay, we hear you. And so what we've been doing is we are bringing this over, and literally we are going to be delivering Azure Stack. And we're delivering it in scale units as small as 4 nodes, 8 nodes, 12, 16, et cetera, et cetera, et cetera. So you can scale this thing out. But it's important to understand, we're not just talking about VMs. We are talking about IaaS services, we're talking about PaaS services, and more importantly, we're talking about a consistent application model. So when you tell your developers, write an application for the Azure resource model, it'll run here on premises, on your gear, in your data center, or you can literally take that app, move it to Azure, or you can bring it back. And one of the things that I've heard a lot of, this has been, I was hearing this over and over again, was companies were telling me, Jeff, we are excited out of our mind about Azure Stack. And what we're doing right now is we're telling our developers, write our new apps on Azure, because it's the perfect place to do test dev. Okay? We can put whatever data we want, it doesn't matter, we can do all sorts of scale testing, but when we deploy into production, we're going to deploy it on Azure Stack, because we know it already works here, and we'll be able to deploy down here. So, yeah, that's an interesting model that we're seeing come out over and over again. Technical Preview 2 of Azure Stack is available right now. And in case you're wondering, that is a screenshot of Azure Stack, not Azure. It looks just like Azure, and people keep saying to me, Jeff, no, Jeff, that's a browser though. I'm like, yeah, that is a browser. HTML5, super touch friendly. I can roll in some servers, pull out my Surface, and start managing my cloud. Yeah, that's what Azure Stack's all about. So you're thinking at this point, Jeff, I thought this was a Windows Server session. Why are you talking about Azure Stack? Where's Windows Server? Because Windows Server is the foundation of all of this. Azure today runs on Windows Server. To be clear, it runs on Windows Server 2012 R2 Server Core. We are in the process of right now moving it to Server 2016. Azure Stack, lo and behold, takes its cues from Azure. So guess what? It runs on Windows Server as well as the base. Now, that basis means software-defined compute, software-defined storage, software-defined networking, but it also means one more super important thing. And I mentioned this already once before, security. And this is, again, this was the one thing I was listening for in the keynote, and I didn't hear this today. This is super top of everyone's mind right now. With all of the breaches, and I know, and you can look everywhere. The FDIC, little kind of an important organization here in the United States. The one, that manages the US economy, they were hacked for 3 years. We actually just found this out recently. Ars Technica published this. The breaches and the attacks are getting worse and worse and worse with less worry about prosecution, because people are attacking from all over. People also want to make sure that, Jeff, we provide a fantastic cost-efficient infrastructure. Not only is it cost-efficient, but it's actually inspired from what we're doing in Azure. In many cases, it's real code from Azure we're actually giving to you on premises in Windows Server, and as the basis of Azure Stack. And then next generation application platform. I heard the word containers mentioned a couple times. I heard Kubernetes mentioned a couple times. I'm not sure, I think I heard Swarm mentioned once. Yeah, we're plugging in all that with Windows Server containers. And in fact, we're delivering new enterprise containers and Hyper-V containers. So I'll talk about that. Again, I got to keep this moving because I've got only a little bit of time and like literally 2 weeks of content here. So what did we build? We built advanced multi-layer security. This release is chock full of security in every way, shape, or form. If you literally take an application today that's running on Server 2008 R2, Server 2012, or Server 2012 R2, and drop it into Server 2016 and do nothing else, we have already made it more secure. Because we have done so many things to harden the platform and to make it actually an active part of your internal security. Cloud-ready application platform, containers. Developers are moving to containers in a very big way, and I'll explain why. Azure-inspired software defined, yes. Compute, storage, and network virtualization, yes. Very much what we deliver in Azure, we're delivering in Windows Server 2016. And in fact, this has been a fantastic, Satya, our CEO, calls this the virtuous engineering cycle. Could not be more true. We take code from Windows Server, we deliver it up to Azure, and they use it. Azure will come up with new features that you've never seen before. We'll actually use it in Azure first, and now we're delivering it in Windows Server for the first time, and you get it, and it's already been tested at planetary scale. That's pretty cool. So, what did we build? Let's talk about security for just a second. So, the incidents are going up, the motivations are big, and there's a huge risk. And literally, this is worldwide. This is every company of every shape, every size. This is healthcare, this is finance, this is academia, you name it. Everybody is being attacked. And this is just a small sampling of what I could have literally a PowerPoint deck just full of these. So, what's also interesting is cybersecurity is no longer the director of IT problem. You know, Phil over there in the corner, who's my director of IT, everything used to be his problem. When there was a security breach, we just fired Phil and got a new Phil. That's not the case anymore. The average cost of a data breach is $4 million. Sorry, Phil doesn't have signing authority for $4 million. This is the CEO's problem now. CEOs are getting fired for this. It also means that liability coverage for a corporation, minimum $500 million. This is not chump change anymore, folks. Security is very much at the top of everyone's mind. The attack timeline is very, very interesting. The attackers out there, all the bad guys are out there. They're doing the research and their preparation. And you'd be shocked how simple this is. Because all you need is a search engine and human nature. And I can get inside your corporation. I can get inside your org. Everyone used to say in the 90s, there were a bunch of bad movies about hacking the firewall. Remember those? Everyone was always, well, as long as the firewall's up, the corporation will be fine. We'll be protected because we're behind the firewall. Like that was some magical mode or something. Today, yes, firewalls are still important. I'm not saying get rid of your firewalls, but the bad guys, they're not even bothering to attack the firewall, because the easiest way to get in is to do a search for the name of your company, do a search for the CEO, then find your org chart, then find out, well, I need to get into IT, so let me find out some of the names on that team, and then send a couple of phishing attacks. Guess what? Ars Technica did a research on this recently, found out over 50% of people that are in IT actually click on those phishing attacks. You know, the things that we always laugh about and say, no one would ever do that, that's too stupid. Oh yes, they do. Now I'm in your org. Now I'm dropping malware inside. I didn't need to attack the firewall, I sent you email. That's how they're getting in. Once they get in, it's on average 24 to 48 hours before they're able to find ways to actually get themselves elevated all the way up to a domain admin, and once they're in, game over. I can do anything I want because I look just like a domain admin. So, if I haven't scared you yet, I'm not sure what else I could do, but that's okay. We're doing a ton of things to literally lock these doors completely. We're actually protecting identity. We're going to protect the OS, whether it's on-prem or in the cloud, and we're doing some honestly brand new technology that literally nobody in the industry or the world has to help secure virtual machines. So let's start with the first one, credentials. Like I mentioned before, social engineering is leading to credential theft. If I can get inside your org and if I can somehow get some phishing and somehow get some creds, I can get inside and do really bad things. There's well-known attacks called pass the hash and pass the ticket. We have literally stopped them dead in their tracks. Those do not exist anymore. If you're running Windows 10 anniversary update, if you're running Windows Server 2016, guess what? Done. It's literally impossible. We don't know any way to do it anymore. We've literally locked those doors, and I could spend a lot of time going super technical into how we're doing it. Suffice to say, they're done. Another thing we're doing is we're actually protecting the admins for the first time. So for the longest time, we've always said, look, if you want to protect someone, just make them user. Okay? As long as they're user, they can't do anything that's going to harm anyone. And we've always said, well, if you're admin, by definition, if this is my system, if this is my server, by definition, my admin, I can do anything I want. I am God on this server. I can inspect memory. If you tell me, Jeff, just encrypt my VM, that's okay, I'm the admin. I can find the keys in memory and I can decrypt it. Anything you do to protect your resources, I can undo because I'm the admin. That is law. That is how computer science works and has been working for decades. This is not a Windows problem. This is a Windows, Linux, Mac, VMware, you name it, every OS on earth has this problem. So, what you really want to do is you want to make sure that I'm not running this full admin 99% of the time. What's always shocking is when we find out that someone's sitting at their desk, they're browsing the web, they're doing their email, they're doing their work, and they're logged in as a full domain admin. No, stop. Don't do that. You should be logged in. I'm logged in as Jeff. I'm doing my browsing, I'm doing my email, great. If I need to make a change on the network firewall, then I should actually upload my privileges to being a full network admin. The way to do that is through something we call just-in-time administration. Through just-in-time administration, I go through a workflow. So now we say, hey, you know what? I need to make a change on the network firewall. I had a meeting with 5 folks on my team this morning, and I'm going to go do this. Great. We agreed I'm going to do this at 10 o'clock. So 3 people have clicked, Jeff has approval to do it because I need a majority vote, and I have a half an hour to make this change. So from 10 to 10:30, I log into the network as network admin. I'm full network admin. I can make all the changes I want, and I go make these changes on the firewall. Guess what? 30 minutes later, I come back, whoops, didn't get it done. Sorry, my mistake. Now my team goes, wait a minute, this should have taken you 5 minutes tops. What's going on? We gave you 30. My mistake, I read something wrong, I need another 30 minutes. So now the team can say, okay, we'll give you another 30 minutes, but if you come back again, we are going to stop this change. Okay, so I get my another 30 minutes, and yeah, it all works out fantastic. Well, this whole process is now audited. I know exactly who approved me, I know exactly who made the change, I know exactly what the change was, and when I was done, 30 minutes later, I literally was back to being standard user Jeff. I didn't have to make any changes to my workflow. That's what just-in-time administration is all about. Fantastic new administration guardrails in Server 2016. Now, a couple things. We, of course, want to make sure that we protect the OS and make it an active participant in your security posture. So we're doing this in Server 2016 because we want to not only protect you against known threats, but we want to protect you against threats that we don't even know about, that haven't been even created yet. So what we've done is we've actually added a whole bunch of new capabilities that literally help lock down the OS, even from threats that haven't been developed yet. For example, Device Guard. Device Guard says, you know what? There's a white list of binaries that can run, period. Even if an admin comes, a second admin comes later and tries to install something they shouldn't on a server, it won't run because it didn't pass the code integrity check. So Device Guard gives me whitelisting for servers. Windows Defender gives me malware, anti-malware in the box. Control Flow Guard is actually technology we've had around for a few releases, but we've actually, it's a compile flag basically when you're compiling code. Well, we've actually compiled Server 2016 with Control Flow Guard. And what this essentially does is allows us to protect from code that's trying to run from places that it can't or shouldn't be. This actually allows us to programmatically say, sorry, we can stop it dead in its tracks. So even for malware that hasn't been created yet, we've already put procedures in place to help guard and protect that. So, as I mentioned before, I've been working on hypervisors a long time, spent a long time doing it, and I will be the first one to tell you virtualization is fantastic. It's not perfect though. And in fact, you could probably find videos of me talking about virtualization back in 2003 where I was actually pointing out that, heaven forbid, virtualization actually creates 2 problems. Yes, I said it. Okay? Guy who loves hypervisors actually said it. Yeah, virtualization creates problems. Let's be real for a moment here. First one, single point of failure. Pretty straightforward. Back in the pre-virtualization world, if this was my server and I was running a database and it went down for whatever reason, hardware, whatever, power, you name it, if it went down, I've got downtime. I got to go fix my database. That's bad, okay? But it was one workload. In the virtualization world, if this is a virtualization host running 50 workloads and that goes down, oh yeah, that's catastrophic. That's not just bad. Okay, well the good news is we solved this one. There's no problem. We actually solved this a while ago. Failover clustering, live migration, shared nothing live migration, live storage migration. We have mitigated this ages ago. This is not a problem. Okay? Second one, nobody's done squat about. This is a real problem. Single point of attack. So with single point of attack, again, if this is my SQL server, and I get into that SQL server, either I'm a storage admin because my database is sitting on the SAN, or I'm the virtualization admin because I am the hypervisor host admin. Guess what? If that was a database running on Metal, yeah, I got one workload, that was bad, but if this is a virtualization host or I'm the SAN admin, guess what? I get everything. I can get your entire infrastructure. And worse, because virtualization actually encapsulates files and VMs and operating systems and data into just a few files, makes it easy. I can literally walk up with my USB key plugging in, walk out the door, and you have no idea I took it. So there's a whole bunch of slides here, and in fact, forget that. I'm going to do the demo. So what I really want to show you is, if I switch to it correctly, and pardon me, this room is a little laid out, little odd for me, so I actually have to do the demo not looking at you. Pardon me for that. So let's start for just a moment. I'm a bad guy, and I could either be the storage admin in your organization who just had a bad performance review. I'm going to get fired on and I know it. So you know what? I'm going to steal some secrets before I leave. Or I'm a bad guy outside of your organization who send a phishing attack and I got your SAN admin creds. Doesn't matter who I am. The point is, I am logged in as a full SAN admin. I own the keys to all of your storage. The point I want to make before I get started here is with virtualization, a Fabric admin can do anything to your and get the keys to your kingdom. Whether it's VMware, whether it's Hyper-V, whether it's KVM, whether it's Xen, period. Every one of these have this problem. No one is immune. In fact, let me show you. So, I'm the bad guy, so what am I going to do? I'm going to log into the SAN, and I'm actually going to go into the virtual disks folder, and I'm going to look for a nice easy attack target. So, we're going to go here into the VHD folder, and lo and behold, it's a domain controller. In fact, there's a couple of domain controllers. Well, domain controller means if I can get your domain controller, if I can get the Active Directory database here, I own you. Your company is mine. I can do anything I want. And because it's sitting on the SAN in a virtual disk, it's real easy. I can literally copy this. You'll have no idea I took it. But first, let me show you how easy it is to attack. Watch as I perform an incredibly difficult attack known as a double click. Watch this closely. Double click. There it is. I just mounted the virtual disk. So now I can go into the NTDS folder, which, if you may or may not know, the ntds.dit file is the Active Directory database. That has your usernames and your passwords. It's the keys to your kingdom. So now what I'm going to do is I'm going to literally right-click. I'm going to copy this. I'm going to put it on my USB stick. I'm going to take this home with me. And now, for the next month or two, I'm going to brute force attack that file. I'm going to do everything because it is encrypted, of course. But guess what? I'm going to brute force attack this for a while. And guess what? Eventually, when I actually get inside of it, I'm going to have a file that looks something like this. It's a key value pair list, usernames and passwords. I can now get inside your company, I can be anyone I want, and you have no idea. Look how simple that was. So, let me show you. Wouldn't it be great if there was a way you could protect your VMs from your Fabric admins? And again, storage admins, virtualization hosts. Any and every platform out there has this problem. So, let me show you how we solve this. First thing I'm going to do is I'm going to bring up Virtual Machine Manager. And in fact, you can see here is that domain controller. You can see, actually, I have a second domain controller which is running, my DC2, which is actually running what we call a shielded virtual machine. A shielded virtual machine is a black box. A Fabric admin, the virtualization admin can run it, but can't look inside it. So let me show you how difficult it is to actually, I'm going to convert now this unshielded VM to a shielded one. Well, you actually click on that, and then you right-click on Shield. And now, what we do is, we actually add the shielding data. Now you may be thinking, of course, what is shielding data? Well, shielding data is an encrypted lump of secrets. And it's an encrypted lump of secrets that is securely delivered to the fabric on which the VM is authorized to run on. And it has a number of secrets. For example, the administrator password has an RDP certificate. So if I need to talk to this VM, guess what? You can't do a man in the middle of attack, because that's there as well. It has a list of fabrics that this shielded VM can run on. I'll talk about more in a second. And finally, it also has something called a volume signature catalog. What this means is, if I go to a public cloud, I want to make sure that the bad guys haven't tampered with my golden image. This makes sure that they didn't. So while this is actually in the process of encrypting that, let's go back and attack the second one. As I already showed you, the second domain controller is in fact already shielded. So first thing I'm going to do is let's double click on it. It says, sorry, the drive is BitLocker protected. It's encrypted. All right, fine, let's try a different attack. Let's go up to Explore. In fact, there's the drive I'm trying to mount. You can see it's got the BitLocker key. So I'm going to try again. And it says, there are no supported protectors on this drive. The drive can't be unlocked. I'm full admin. What it's actually saying is, this error is saying, sorry, I can't decrypt the key to decrypt the volume. Sorry, you're out of luck. You see, the person who's actually the admin of that VM is the guest OS admin, not the hypervisor admin or the storage admin. All right, let's try another thing. I'm not done yet. I'm persistent. Let's go to Hyper-V. So in Hyper-V, you probably know that here I've got some running VMs, and you can see there's my live thumbnail. So as this VM is running, you can see what's happening live in the thumbnail. And if I double click on that thumbnail, what will happen is it'll actually show me a console connection. There it is. Well, if I go to a shielded virtual machine, you can see, well, there's no thumbnail. And in fact, if I double click on it, what will I find out? It says, sorry, you can't connect to it. You have to use an RDP connection. And guess what? That requires a certificate. No man in the middle of attack. So think about what you've seen here. You've seen a shielded VM that even though I'm the full admin, I can't get in. A shielded VM is essentially a black box. And with this black box, I can say it literally only runs on this hardware. If I, as the admin, plug in my USB stick, take it home, plug it into my personal system where I'm full admin, guess what? Doesn't work. It's encrypted. If I talk to the storage admin and he grabs it and takes it home, nope, sorry. It's fully encrypted. With a shielded VM, it will only run on a designated fabric. I can tell you right now, every customer I have talked to and have shown this to, they're pretty much out of their minds about this. They want this now, they want this yesterday, they want this deployed. This is built into Server 2016, and literally it is the only virtualization platform in the world that protects you from fabric administrators. This, you can certainly expect to see, will be going up to Azure as well, because Azure has a vested interest in this as well. Azure wants to be able to say, guys, you can bring your VMs, and if you run it shielded, guess what? Even in Azure, we can't open it up for you. We can't help you if you have a problem because you have the keys. This is about putting the control of the virtual machine back to the guest OS administrator, not the fabric administrator. So this is all part and parcel of what's built into 2016, and I could literally spend a couple hours just explaining how all of this works. But I can tell you, it's pretty amazing. That was shielded VMs. Now for the hardware standpoint, I do want to point out, we do require latest modern hardware on this. We do have some hardware requirements. And I'll be honest with you, when I've told customers about it, they're like, yeah, we don't care. Just tell us what it is because this will be all we buy from here on out. So you've got to have SLAT and VTX. Those are processor technologies, been around forever, not a problem. These are the ones that get tricky. You need a TPM. TPM, Trusted Platform Module's been in your phone, it's been in your tablet, it's been in your Surface, it's been in your forever. Servers in general don't have these. Well, the good news is we've been working with all of our OEM partners like QCT. Guess what? They're all shipping with TPMs now. So TPMs, but that means you got to have a pretty recent server, like within the last 6-10 months. Nothing, your 4-year-old server, not going to do this. VTD and UEFI. So we're being very prescriptive about this and we're telling folks exactly what's needed, but we are delivering a completely new level of virtualization protection. And I can tell you right now, this literally took years. I meet with common criteria folks. We do common criteria certification at Microsoft all the time. And for years, people would walk in and these guys would come in and say, Jeff, what are you guys doing about the rogue administrator problem? And I would say, yeah, we know about it. It's a really hard problem. It's been a problem for decades. We're working on it. This year I showed them this and they just about flipped their minds. There's a question.
What if the government subpoenas you? Can you still open it?
I can't open it. You have the keys. Yes?
What happens if the guy dies or quits? Are you SOL?
You better have a solution for it. I don't have the keys. Yeah.
What about do you have a backup and then your hardware is dead and then you have to replace the hardware and restore it?
So a common question is backups, disaster recovery type thing situation. Totally thought of that as well, because guess what? This all integrates into our disaster recovery solution. So when you configure a shielded VM, one of the things you configure is what are the fabrics it can run on? So let's say my company is Contoso. That means literally this VM will look down and we'll actually talk to an external entity called the Host Guardian Service, which will say, is this host trusted? Has this actually been measured and tested? Does it have a code integrity policy? And is it part of the Contoso? And if it passes all those tests, then the shielded VM will turn on. When you set up for disaster recovery, make sure that when you set up your shielded VM, just say, oh, by the way, this is Contoso Site 1 and this is Contoso Site 2, and this VM can run on either one of those fabrics. So you could totally fail over without any issue. All right, I've got to keep moving because literally 2 days of content, 1 hour. All right, I'm going to keep moving. Transforming the data center. So we've been heavily focused on what we do in software-defined compute storage and networking for a very, very long time. And we have continued to drive the state of the art. Windows Server 2016 Hyper-V scale limits. Yep, we blasted the numbers again. I'll be honest with you. In 2012, we did this. When 2012 R2 rolled around, I talked to customers. I said, do we need more? And honestly, they said, nah. So guess what? I didn't even bother to up these in 2012 R2. I literally left this exactly the same. It wasn't that we couldn't do it. It wasn't that we didn't want to do it. It's just there was no customer need. When 2016 rolled around, guess what? A lot of customers said, well, yeah, we would like it a little bit bigger. But you know what? Who really needed it bigger was Azure. Because guess what? This is what they run. Azure said, Jeff, we need the biggest, baddest VMs ever. I said, really? They said, yes. How much memory can you stick in a server? We'd like 24 terabytes. That's 24 terabytes of RAM in a server. I don't even have 24 terabytes of storage when I look at all the personal systems I own between both my daughters, my wife, my mother-in-law, my personal systems, and all the systems I have at work. I don't even have 24 terabytes of storage. This is RAM, okay? Up to 512 logical processors, up to 12 terabytes per VM. So if you want to run SAP, you want to run HANA, you want to run SQL Server with Hekaton doing in-memory, this is the absolute best way, bar none, period. End of story. 240 virtual processors per VM, that's not a typo. It's 240 virtual processors. Funny note, Task Manager in Windows Server, we actually had to put a scroll bar when you have 240 virtual processors on there. That's how big that is. So biggest, baddest, and this is all built into Server 2016, both standard and data center. You don't have to buy the crazy super expensive versions. Nope, you can get it in standard as well. So we also did a whole bunch of things about reliability and resiliency, and I could spend hours just talking about this. I'm actually going to mention one of my favorite ones that actually seems to be getting lost, load balancing. So imagine you set up a 4-node cluster, roll it into an office, and say, hey guys, you know what? We got some software default, we got some virtualization running. By the way, we'll do all the automatic load balancing for you. It's turned on by default. You don't need to do anything. It's set it and forget it. On, enabled, boom, love it. So from a software-defined storage, we have been crazy busy working on storage. We just started doing this work back in 2012, then in R2, and in 2016, we are just crushing it here. So we have storage replication built into the box. So as I think about the hurricane situation happening in Florida right now, I am very much reminded about where we were with Hurricane Katrina over 10 years ago. Hurricane Katrina was a big wake-up call for us. I remember personally trying to understand how businesses lost everything when disaster recovery solutions had been around for a very, very long time. Turns out they were really expensive, they were really hard to use, they had lots of complexity, and just people were daunted by the task. So we just made it real easy. We included replication in the box, we included Hyper-V replication in the box, we included the scale-out file server, but this time we actually added one more piece of the puzzle. We can now do asynchronous and synchronous replication in the box to do stretch clustering between scale-out file servers. So replica is now in the box in addition to what we've been doing in Hyper-V replica. And of course the big one, and one of the reasons I'm excited to be here at this HCI conference, is the work that we've been doing in Storage Spaces Direct. Storage Spaces Direct is about giving you, again, let's pool local built-in disks, okay? By the way, let me take a moment to say, if you have your SANs, if you love your SANs, if you love your fiber channel, great. It all continues to work. We can plug in Server 2016, we can work with whatever fiber channel, whatever iSCSI thing you want to work, it all just works. But customers have told us flat out, we are moving to software-defined storage, please make your investments there. So that's what we're doing, that's what we have been doing. And so with Storage Spaces Direct, we're talking about focusing on solutions that our customers are looking for. The first one is a converged solution, a disaggregated one. In this one you can see we have a separate tier of systems for your compute. So I got my compute and my memory here, and I'm using standard Ethernet. Can be 10, can be 40, can be 100 gigabit, and I'm talking to my scale-out file servers. Okay? Now, there's a natural reason to want to use this. This is nice for larger solutions. We also, of course, hyperconverged. We did a ton of work in 2016 to make sure that hyperconverged rocks. So, with hyperconverged, I can literally have 4 nodes. Guess what? Each one of these has local disks. I could have NVMe storage. I could have SSD storage. I could have PCI storage. I could have them all tiered. I could have spinning Rust in there as well. But the important thing is I can have all of these together. And then, with the magic of RDMA, remote direct memory access, we can give you killer performance. And I cannot overstate this enough. Because if you're doing hyperconverged and you're doing this without RDMA, you are killing your scalability and you are killing your own perf. Let me explain why. If this is 4 nodes and this is 10 gig, you have 2 10 gigabit NICs in each one of these servers. How does scale-out storage work? Well, when a VM does a write, it writes to 2 other locations. So you're actually writing to 3 locations simultaneously, which means it has to go over the network. Well, if you're on 10 gigabit Ethernet, even on a modern Xeon, guess what? That can use 2 cores to do all those writes. Well, if I have a massive SQL server up here that's doing a ton of writes, and I've got to replicate those writes, and another one fires up and starts doing a ton of writes, guess what? Your overall scale is going to go down. Your overall performance is going to go down. What you want to be able to do is you want to have as minimal impact when doing writes as possible. Enter RDMA. With RDMA, remote direct memory access, those writes are essentially free. Let me say that one more time. Those writes are essentially free. So I just gave you 2 cores back in every one of those servers, which means your perf didn't go down, your scale didn't go down, and in fact, you're getting crazy performance. So what does that crazy performance look like? Let me show you. So we've been working on this for some time with our friends over at Intel. So what we did was we set up a 16-node cluster. This 16-node cluster has 704 VMs running VM Fleet. This is publicly available. We actually stuck it up on GitHub. So anybody can do this. Okay, VM Fleet. These VMs doing a ton of I/O. Okay, this is like trying to make real world workflows here. So the first thing we did was we said, all right, let's fire this up. 100,000 IOPS per server. Wow. By the way, this is a 70-30 split. So 70% reads, 30% writes. Pretty indicative of what's going on in the real world. Okay? This is not some fictitious 100% reads. Okay? 70-30. And you can see we got, wow, 100,000 IOPS per server. That's not bad for starters. Now, let me tell you, we actually, to actually do that, we actually limited ourselves. So let's actually up the limit. Well, I wonder how much faster we could go now. So let's see what would happen. Let's see, the I/O performance is now 1.5 million IOPS, now 1.9 million IOPS, now 2.9, now 3 million IOPS. Yeah, we're getting over 200,000 IOPS per server. Not bad. Oh, and by the way, with less than a millisecond latency. This is using standard off-the-shelf servers and RDMA. I wonder if we can make it go faster. So we kept on going. We said, well, what would happen if we actually, I don't know, let's take the safeties off. Let's go even faster. Well, now you can see we've hit 3 million IOPS, 4 million IOPS, 6 million, yeah, 375,000 IOPS per server. This is using off-the-shelf Windows Server 2016. Boom. Did an hour fly by that quickly? Wow, okay. I told you, it's flying. All right, I gotta move. Azure-inspired software-defined networking, very quickly, because I could spend a ton of time on networking. Here's the thing you need to understand about this. In Azure, we have a massive network. Anybody watch the Olympics, the Rio Olympics? Anybody? Anybody? Yeah, a few people? If you did, that all came from Azure. Okay, we set the world records again for live streaming. We did it last year, last time at Sochi. Then we blew away those records this time with Rio. Spoiler alert, that's all delivered through our SDN stuff. That's all delivered through software-defined networking. Okay, so we then said, well, guess what? Let's take that distributed firewall. Let's take the network controller. Let's take the Azure data plane, and let's actually give it to you. Let's actually put it in Windows Server 2016. So you're getting that. So even if you say, Jeff, we're not using Azure yet. Well, if you use Server 2016, you actually are, and you're getting a ton of benefits. And guess what? It's already been tested at planetary scale. So that's pretty awesome. And you know, this has been tested literally at millions and tens of millions of virtual machines and workloads running around the world. Again, just huge work going on here. And the whole goal is really to try and ease the complexity. If you look at a traditional data center network, you got a whole bunch of racks here, you got a whole bunch of switchers here, you got a whole bunch of hardware load balancers and firewalls and all that stuff. And if I deploy a new application here, well, I've got to set this, and I've got to set this, and I've got to set this. And if I move that, oh gosh, I got to switch this, and I got to switch it. That's how you used to do it. In the software-defined networking world, we want to ease this up because agility is something that customers want. Security is something that customers want, and reducing costs is definitely something that customers want. So what we're doing is saying is, yeah, you know what, that's software. When I deploy an application, guess what? All of that policy is part of that deployment. And if that thing moves and live migrates or load balances, guess what? The policy just moves with it. If I want to use microsegmentation to get me better security, not a problem. And guess what? Again, this is all built using the building blocks coming from Microsoft, from our Azure public cloud. And this is switching, routing, load balancing, firewall, edge services, quality of service. We didn't just throw in a couple things and say, here you go. No, this is massive, folks. This is really, really massive. And our network controller, again, all part and parcel built in the box, is the key to what makes all of this work when you deploy applications and how it configures policy for the rest of my fabric. One of our customers over at Convergent, the CTO, the ability to spin up a software-defined network in about 8 minutes while limiting a $20,000 cost is a huge benefit. We've publicly said this before. I think the number is actually low now, but on an average day, we'll spin up about 50,000 new networks in Azure. Okay, humans don't do this, folks. Okay, because any one change could have catastrophic effects. What you do is you create a very flat network, and you use software-defined networking so that people can create all the networks they want, and we'll just keep building more. We are bringing this on premises in Windows Server 2016. And again, this is the basis of what we do in Azure, and it's the basis of what we're going to be doing in Azure Stack. So I got to zip past this because, again, I know I'm out of time. And I really want to get to NanoServer. NanoServer is a new deployment option for Windows Server. In the past, we've had the full enchilada. Think of Windows Server with all of the features, all of the roles, Active Directory, file, print, the fax server still in there, a GUI, a browser, you name it, it's all in there. It's huge, it's about 9 gigs. Server Core is the way we've been telling you to deploy Windows Server, and this is how we deploy it up in Azure today. This is about 5 gigs on disk. It still includes all of the roles and features, but it's managed remotely. There's no local GUI. Now we're talking about NanoServer. NanoServer is teeny tiny. It's 400 megabytes. NanoServer is 64-bit optimized. This is the kernel. There's no roles and features. okay? No print, no fax, none of that stuff. What you do is you do two things with Nano Server. A, you deploy it on metal. It's spectacular for your Hyper-V server or your scale-out file server. Or you put it inside of a container or a VM and you start building applications on it, like Node, .NET, .NET Core, the mean stack, whatever. And boot time, setup time, from literally a machine has nothing on it till it's actually got Nano Server is 35 seconds flat. Like literally a black box to, oh, it's booting and running, 35 seconds. Boot time 9 seconds, boot time of server core 85 seconds, and then again we're talking first boot here. So dramatically lower, fantastic for cloud, fantastic for application development. And to manage it, you can use PowerShell, you can use management MMC consoles we've had in the past, and we're also building a very easy to use web management console as well. So if you literally want to be able to point and click on your phone or your tablet or your iPad or whatever, it's all HTML5, it's all beautiful and easy to use. And to create the images, we actually give you an easy to use image builder. If you put in, like if you're used to installing Windows, like putting in a disk, there is no disk, okay? You literally actually create the image and then you apply it to the server and you actually do a bare metal install. So it's a little bit different, but we've made it really easy. And in fact, we include PowerShell, so if you want to automate these and build these images, you can do that. All right, I am out of time and I'm about to get kicked out. So with that, I want to say thank you guys very much. A huge thank you to the folks over here at QCT. It's really a pleasure to be here. And hopefully you guys get a chance to play with the new hyper-converged infrastructure, the new software-defined capabilities, and it runs awesome on the QCT hardware. Thank you guys very much. And here are just a couple of examples right there. Thank you very much, guys.